my name is Wouter, and in this video I would like to share a project that I've been working on called Basecode. So what is Basecode? Basecode is a tool to quickly build web applications. The code it generates is based on Kotlin, Spring Boot, React through Next.js and GraphQL. So you may be wondering, like, why did I build Basecode? I mean, there are other platforms like Ruby on Rails and Django out there that also allow you to quickly build web applications. Well, first of all, I really like working with Kotlin and I really like working with Spring Boot because Kotlin is statically typed and Spring Boot provides a rock solid foundation. Of course, there are other generators out there that also generate code with Kotlin, but I haven't found a generator yet or a platform that is able to generate code the way I like it. And the way I like it is to have code that is very loosely coupled. So where different parts of the applications are as little intertwined as possible. And furthermore, I would like to have a platform where that doesn't provide me bells and whistles, but just gives me what I need when I need it, but not more than I actually need. So in this video, I would like to show you how you can use Basecode by creating a blog application. And yeah, let's dive in. So in order to use Basecode, there's a command Basecode, and I can say Basecode new, like com.wouter blog. And here com.wouter is basically the group ID that's used by Maven, and blog is the artifact ID for the backend. And so what will happen is it will now generate the backend of the application. So because I also want to include a front end, I'll also generate the front end. And if we now open it in IntelliJ, then basically what you will see is the minimalistic approach that was taken. Because if I now look at the server, basically there's nothing there other than an application.kt file. And also the same on the front end. There is just a dummy welcome page. And by the way, I need to run npm install because otherwise it will tell me like, hey, it will show me red. But it has an index.tsx, basically an app.tsx, which is basically the wrapper for all the pages to be used. And because the front end is based on Next.js, some basic components that are basically wrappers around the base HTML components, but can be reused and easily styled so that you don't have to tightly couple your components with, for example, a UI library, but that you have essentially a proxy in between. And there's a layout component, which is basically the default layout that's being used. So now let's create a scaffold. Let's call it post, and let's give it a title and contents. And here I state contents is of type text. So now it generated it, and as you can see here in app, I now have post with post details, post form, post list, and here I also have post. As you can see over here in the domain package, basically everything is bundled together. So it's packaged by feature within the domain. But if you zoom a little bit out, then you also see like it's packaged by layer when appropriate. The reason it's packaged by layer by feature within the domain is because things that belong together, you often want to edit them together. So instead of having a package called service, controller, etc., I try to bundle as much coherent classes as possible. In the case of the post resolver and post data loader, those are also really tightly coupled because that's basically the GraphQL API. And basically these may eventually drift a little bit from the domain itself. So that's why those are separate. On the front end, post list for elements of post. And here you can already see like, hey, it says, for example, it queries, in this case, for example, a list of posts. And so what you can essentially see, each component is in control of their own data. And that's also throughout the application that you will write. What you will basically see is that each component is in control of its own data. So let's open a browser and let's navigate to the application. But first, of course, I need to start it. And also let's start the backend. And before I can actually run the backend, I also need to run Docker compose up, which will spin up a Postgres server that runs locally. And then it should be able to spin up. And as you can see, like by default, it shows that index page that we just saw earlier. But if I now go to posts, here I can see blog, which is the name of the application, breadcrumbs over here, and here are the available actions. And what you can already see is that all the components are unstyled, which is basically connecting to the principle of giving you everything you need, but nothing more. Because like in every application, you will probably use a different set of components, different styles, etc. So let's create a new post. Basecode, a cool project for you. Check it out. Let's save it. And now it goes back to the list of posts. Let's tweak the list of posts a little bit so that it looks a little bit more like a list of posts. So I go into post list. And here you can see, hey, I use these generic components that have already been defined. But I can also just keep things simple and say, hey, I want to go over all the posts. And say like this, just put an li link href. And let's remove the contents from here, from this list. And let's close the link tag. And then let's remove the list. We won't need it anymore. And then let's remove this mutation. And now it looks a little bit simpler. Like now you have just a list of posts. And if we go in here, we see the post details. I think it would be nicer if we would just see the header. And let's also add the contents. All right. And of course, what is a blog without comments, right? So let's add comments. Basecode generate scaffold, comments. Let's create a reference between, or a relationship between comments and posts. And let's say contents, text. And now it generated comments from us. Now, one really cool feature of Basecode is how it deals with relationships. And what I mentioned earlier, the whole principle of having everything as loosely coupled as possible. You also see it how it deals with relationships between different components, for example, on the front end. For example, if we now want to show the list of comments that are related to a post, then basically all we have to do is say comment list post ID is equal to post ID as string. And that's because here it uses the next router, and here post ID can be either a string array, or undefined, but in this case we know for certain it's just a string. And just by writing this, I should now have a list of comments. And do take note that when I ran the generator, basically everything in here was related to comments, and not a single file of posts have been changed. Which is really cool, because that means that essentially if you would at some point remove the comments, basically the whole application would still work. Maybe you just need to change one file on the front end, but other than that, everything would still work. And that's because everything is so loosely coupled that it will just continue to work this way. And similar to the list of comments, let's also add a comment form. So I'll say here, post ID is post ID string. And now we also have a place to add a comment. Let's tweak it just a little bit by stating comments here. And then let's quite quickly restart the front-end server so that it regenerates the model. So now we have comments here. Let's also make this a UL construction like we had before. So let's just say data.comments.map comments li data or comments dot contents. Add a key here, comment ID. Let's clean it up a little bit, remove the delete, and this mutation right here. Even though a linter is available in the source code, I don't have it set up right now in my IntelliJ, so that's why I had to change it manually. So now we still don't have anything here, but let's continue with the form real quickly. Continue with the form contents. Let's remove this part over here. And just for simplicity's sake, let's add a BR here. So now if I just add a new comment, like say, hey, log this project, what you'll see, essentially, it just adds that comment. Which I think is really cool, because essentially these two components, they don't have any relationship whatsoever. There's no linking between them. There's no global state management. At least that's exposed to the developer on the front end. So how does that work? Because I think this is one of the core features that Basecode provides when it generates code for you. Basically, Basecode is based on a library on the front end called Wirequery. And what it allows you to do is essentially a really simple or relatively simple GraphQL library that also takes care of the state. And when you perform a mutation, you can essentially tell that library like, hey, I'm now changing something of the type comment. And on another location within the program, you can say, hey, I have this query that is, for example, a post, and it contains like comments or stuff like that. And then you essentially specify the types, or it automatically gets it from your query. Although there are some caveats over there, so it's better to explicitly specify those types. And in that case, if you do that, it's able to essentially invalidate this data over here once a mutation is triggered over there. And so that means that essentially this whole idea of state management becomes so much simpler. Basically, you can create a whole application and never think about state management again if all you do is fetch data from the database and update different components within your application. Even though you have like the wildest queries, as long as you know like, hey, this mutation essentially does something with this type, and this mutation or this query does something with this type. It's essentially all you need. And it's a great library for that reason. Even if you wouldn't use Basecode, I would really want to recommend this library. So that's the front end. Now I want to add, of course, authentication, because what is a blog without authentication, right? So also here, we can simply say Basecode generate auth. And what that will do is essentially create a login form and a registration form. So I don't want to show you right now how to set up the whole authentication with posts and the comments, because it's a little bit of work and this is just a short introduction, but just know that it's there and it's available and it's not that hard to configure. So for the rest of the video, let's just dive in the code and see what has been generated for us. And along the way, I'll also explain some of the design decisions that went into making Basecode. So let's start with the backend. Essentially what we have here is we have a domain package. So I already showed a little bit of the structure, of course. So the post and all these classes, they are really coherent. They belong together essentially. And here as well, we have application, and within application, we now have security. It wasn't there before, but that's because of the authentication. And we have GraphQL. So essentially two different layers. The security is basically boilerplate for adding security features to your application. Basically, like using bcrypt for Spring Security, things like making sure that GraphQL works with data loaders with a secure context, stuff like that. Then also a method for loading the user, and of course Spring Security configuration, like which endpoints are allowed, stuff like that. Then we have the GraphQL package. So here, if I look at post, I have a post resolver, which essentially corresponds to a schema over here. And by the way, before you continue, maybe it's best now to explain why Basecode uses GraphQL. I've developed a lot of applications in the past, and a lot of them had a REST API. However, there were a couple of problems that I ran into whenever I built an application based on a REST API. So the first one is that whenever I would build a front end that connects to the back end, and I did anything out of the ordinary on the front end, that then I would really have to change the backend API. So if you have just a really simple CRUD application, it's fine. But over time, your API becomes more spaghetti, and yeah, basically it's hard to really keep a nice API. That's the first reason. And the second reason is whenever you're dealing with relationships. So for example, in the case of a post and a comment, then what you would often do is introduce mappers. So essentially you take, for example, imagine you have an endpoint for fetching all the posts, and you also want to have all the related comments in there. then at some point in your application, you would have to write a service that would first call the post service, then the comment service, and then probably have some kind of mapper to stitch those two together. And it's a lot of manual work, and it's also really hard to make sure that all these different concerns are well separated. But by using GraphQL, and so Basecode uses DGS for its implementation, basically it does it all for you, all this stitching. So basically, if you would query, for example, post, and then also query the related comments, then basically it would fetch the posts and then ask the data loader like, hey, I have these posts. For example, if you fetch 10 posts, for each of these posts, also give me the comments, and then like under the hood, it does all the stitching for you. And that's such a much better experience than if you would have to do it manually. So let me show you how this looks. So for example, here I have a post, and in here, in comments, basically what I do here is I say, hey, comments by post. So if the parent ID or the parent type is post and the field of comments is being fetched, then I want to use a data loader. And then here I have the data loader, which will then essentially load these comments. And also what's really nice about this is you don't have to worry about the so-called n+1 problem. So that means if you load 10 posts, you don't want to do 10 queries for fetching the comments. You just want to do one query for both, one query for the posts and one query for the comments. And that's basically all being taken care of for you. So yeah, definitely I would recommend GraphQL for this. From the resolver, we eventually go into the service, which is over here. And for example, for find by ID, we just call methods in a repository. So as you can see here. And this may look like Spring Data JPA for those of you who know Spring Boot. But actually, Basecode generates code with a different library called Spring Data JDBC. And Spring Data JDBC is a lot newer. It's basically, it looks a lot like Spring Data JPA, but it's much simpler. So what I mean by that is, whenever I used to use Spring Data JPA, I often found myself struggling with, hey, is this entity now persisted? Why does it set an ID in this class? Like it did all kinds of magic stuff I wasn't expecting it to do. It had like different caching mechanisms, and it, at least for me, as a newcomer back then, starting to use Spring Data JPA, I thought like, oh, this is so complex, it's so confusing. Well, all I want is to just query something or save something. And essentially that's what Spring Data JDBC allows you to do. Instead of not knowing when something is actually persisted, like I believe in Spring Data JPA, it's sometimes even possible like, hey, you don't have to call persist, it just does it at the end of the transaction or something. Here it's really simple. You say, hey, save, it will save. Query something, it will query that. There's no magic. And that makes it so much easier to work with. So really great job by Jen Schouder from the Spring team. And yeah, I really recommend this to everyone using Spring Boot. So if we go back to the service, what's also interesting over here, when we query something, it's also mapped to a domain object. So basically, when you fetch something from the database, it retrieves an entity. But if you communicate with the outside world, it could be the case that the entity is different than what you want to communicate to the outside world. For example, in the case of an entity, before it's saved, the ID is of course null. But if you communicate out to the outside world, you know it's never going to be null because it's fetched from the database. So there could be a difference between the entity and what you want to communicate outside. And for that reason, there's an entity object and the essentially DTO or data transfer object as well. And the next thing that I think is also interesting is whenever you delete something or you create something or update something, an event is published. So let's have a look at post. So in case you delete a post, it will publish an event, post deleted event, in this case with just one post. And basically this is being captured by the comment listener, and that will essentially also delete posts by ID. And what this allows you to do is essentially, instead of having the post service say, hey, delete all these related comments, which would, if you would first say like, hey, the comments depend on posts, but not the other way around, you would break essentially that abstraction. But by doing it like this, essentially you can reverse that dependency and then still have the comments only depend on posts. But you may be wondering, like, why not just use a foreign key, for example, and do an on delete by cascade? And the reason for that is within a single aggregate, I think it's totally fine to do it, but within different aggregates, and these are what I consider aggregates. I think it's much easier to work with if you do it yourself, and also it doesn't break abstraction, because if the post would delete comments, then like it's logic that's implicit and not being handled within this package. So it's magic essentially. And also basically I derived this opinion also from the talk of Jen Schauder about using Spring Data JDBC. So if you watch some of his talks, he'll also explain it in more detail. So yeah, essentially events. It's really cool. Of course, we also have users, and basically it contains what you would expect, like a register functionality. And for example, the resolver also contains methods like logging out, for logging in, etc. So I already mentioned the schemas. There are also database migrations for creating a post, creating comments, etc. And just wanted to show you, everything you see here is also coming with a test. So there are integration tests for post, there's also unit tests, etc. On the front end, basically the same. Here also this minimalism applies. And basically here I say default layout. By the way, if you look at the structure, pages, then we have posts, and post ID was between square brackets, and then we have, for example, new or index. And essentially what you can see here is that the pages correspond with the URL that's being used here. So for example, auth register, I'll find auth and then register.tsx. And that's basically how Next.js works with using the page router. There's also something called an app router, but currently Basecode is built using the page router. Let's have a look at, for example, posts. So I have my post list here, and let's see. So I have my post list over here. And so basically here I have my query, and basically the idea is each component is fully in control of its own data. So like I already explained with the idea of Wirequery, that's because of Wirequery, we're able to do that. So here I specify the query, and yeah, basically here the post. And the same for forms. I use Formic for handling forms. Just basically what you would expect. Post details, and yeah, as I mentioned, there are a number of more generic components like form, basically unstyled. I think that's the most important things of Basecode. Some interesting to mention. Why did I choose for React and Next.js? Well, Next.js has server-side rendering, and essentially it has React. React is really great because it has, I think, the largest ecosystem out of the three most important libraries like Angular, React, Vue. I believe it has the biggest ecosystem. At least when I first implemented Basecode with Vue a long time ago, I struggled with the ecosystem, and that was for me the reason to also start using React. I used Angular quite a bit in the past, and I think what's really nice about it is that it's very opinionated. What I don't like about it is that it's very opinionated. And basically what I mean by that is if everything is the way you like it, the way you like how it's structured, like, then it's perfect, right? But as soon as you want to do something that doesn't really follow the essentially Angular way, I believe it's a little bit more difficult than if you were to use React. And for example, GraphQL is also built by the authors of React. And so that just integrates nicely. And for example, for Wirequery, which really allows this decoupling on the front end, which is so essential to this whole tool, that's also a library. At least at the moment I implemented this, I didn't see something similar available for Angular. Just like on the backend, there are front-end tests, and I guess I covered everything that Basecode provides. I've used Basecode for I've started the project around 4 years ago, and I just used it a lot for building my own personal projects. For example, I built Wirequery. It's essentially a tool for doing session replay. And this whole app is based using Basecode. And basically what it allows you to do is you can record a video essentially within an application and then combine that video with data on the backend. Really cool app, I think. And I think it's also worth checking out how it's structured to get an idea how essentially Basecode can be used in a real world application. So essentially 4 years ago, I started writing Basecode. Of course, I didn't write every day on it, but I wrote projects using that tool. And then every time I thought like, hey, well, this can be improved. I improved Basecode. And over time, I came to the conclusion like, hey, now I really like how Basecode is structured. And now I want to present it to the world. So yeah, that's Basecode in a nutshell. I really hope it can be of value of you, and I am just really curious if other people would use it. Like, what do you think of it? Would you think like, hey, I would structure the code a little bit different than for whatever reason? I would love to discuss these topics with you and really just engage with the people that that plan to use it. I'm really curious what people will build, and yeah, it would be so cool if this project can really help other people to essentially build their dream project, right? Because at least that's what Basecode is for me. Just whenever I have an evening free, then I just love coding, you know? And I can think of something like, hey, I want to build this app. When I didn't have Basecode, it took me sometimes just weeks or months to build the overall structure, and I had to think about design decisions I didn't want to think about. And I just held on to Kotlin Spring Boot because I've been coding with Kotlin for about 7 years and even longer with Java. And I just wanted to use this stack. And at least for me, Basecode makes my life so much easier whenever I want to try new things and start building. Yeah, so I really hope it can be of the same value of you. And if you like the project, please consider giving it a star on GitHub. If you like this video, please consider giving a thumbs up. And if you want to see more of these kinds of videos, I'll be probably building or creating more of these videos where I write an application and discuss more technical topics. Then yeah, it would be so cool if you subscribe to this channel. That's it. Thanks for watching, and I'm really curious what you can build with Basecode.